Hello everyone. So today we will start solving some problems from chapter 5 of NCERT 11th standard. Okay. So the initial problems are a bit easy, so we will go through them quickly. So question 5.5. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? Now, mass of the body is given to be 20 kg. The retarding force F is given to be 50 Newton. So net force on the body is minus 50 Newton. So we will use F is equal to ma to find acceleration. Therefore, acceleration A would be F upon m. So this would be minus 50 divided by 20. So minus 2.5 meter per second square. Minus 2.5 meter per second square. We know that initial velocity u is given to be 15 meter per second. Now if you see this, we have considered the rightward direction to be positive. The rightward direction to be positive. Therefore our force is negative and acceleration is in the direction of the force. Therefore acceleration is also negative. And we have to find how long does it take to stop the body. Therefore final velocity is 0. Time we have to find. Time is question mark. So what we will do, we will use first equation of motion. V is equal to u plus at, which we can rearrange as t is equal to v minus u upon a. So this is 0 minus 15 upon minus 2.5, which comes out to be 15 upon 2.5, which is nothing but 6 seconds. Then question 5.6. A constant force acting on a body of mass 3 kg changes its speed from 2 meter per second to 3.5 meter per second in 25 seconds. The direction of the motion of the body remains unchanged. What is magnitude and direction of the force? So what we will do is first we will find the acceleration and then we will use F is equal to ma to find the force. And because the body's direction of motion is not changing, force would be and the acceleration would be in the direction of the motion because the speed is increasing. Let us see. Initial velocity u 2 meter per second, final velocity v 3.5 meter per second. Time that has passed is 25 seconds. Mass of the body is 3 kg. Mass of the body is 3 kg. So again we will use first equation of motion. V is equal to u plus at. Therefore rearranging it, we will get acceleration is v minus u upon t. So this is 3.5 minus 2 upon 25. So this is 1.5 upon 25. Let us multiply it by 4. So this would be 6 upon 100. So 0.06 meter per second square. 0.06 meter per second square. This is the acceleration. And to find the force is mass into acceleration. So this would be 3 into 0.06, which will come out to be 0.18 Newton. So force would be 0.18 Newton. Acceleration is 0.06 meter per second square. Because 5.7, a body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction of acceleration of the body. Now directly we will calculate the resultant force. So magnitude of the force would be, because they are perpendicular, we can directly take their squares and add them and then take the square root. So this would be 8 square plus 6 square. So this would be under square root 64 plus 36, which would be 10 Newton. So magnitude of the force would be 10 Newton. And what would be the direction? Let us draw this triangle. So this is 8, this is 6, this is 10. Okay. Because this angle is theta. Tan of theta is opposite upon adjacent. So 6 upon 8, which is 3 by 4. So this is 3, 4, 5 triangle, which would make This implies theta is tan inverse 3 by 4, and we know in 3, 4, 5 triangle angles are 37, 53 and 90. So this is 37 degree. Acceleration would be force upon mass, so that would be force is 10 Newton, mass m given is 5 kg. So it will be 10 upon 5, which will be 2 meter per second square. So acceleration would be also in the same direction as the force, and its magnitude would be 2 meter per second square. 5.8. The driver of a three-wheeler moving with a speed of 36 km per hour. So initial speed of three-wheeler is 36 km per hour. Let us convert it into meter per second. So 36 into 5 upon 18. This would make it 10 meter per second. 10 meter per second sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds. Time is 4 seconds. Bringing to rest in 4 seconds, just in time to save the child. What is the average retarding force? So first we will find the acceleration, then we will find the force. So because the three-wheeler is coming to rest, final velocity is 0 meter per second. Therefore acceleration is change in velocity divided by time. It also can be derived from first equation of motion, which is 0 minus 10 upon 4, which is minus 2.5 meter per second square, because the acceleration would be in the opposite direction of motion. Now we have been given mass of three-wheeler. Mass of three-wheeler is 400 kg, and mass of driver is 65 kg. Therefore total mass m will be mass of three-wheeler plus mass of driver, which is 465 kg. Total mass is 465 kg. Therefore force, the retarding force would be mass into acceleration, so it will be 465 multiplied by minus 2.5. So this would be 25 into 5, 125. 25 is 150 plus 12, 162. 100 plus 16, 116. So it would be retarding force is minus, so retarding force is, so we don't have to write minus, so retarding force is 1162.5 Newton. Question 5.9. A rocket with lift of mass 20,000 kg, so mass is 20,000 kg, which is 2 into 10 to the power 4 kg. 2 into 10 to the power 4 kg is blasted upwards with an initial acceleration of 5 meter per second square. So acceleration is 5 meter per second square. Calculate the initial thrust of the blast. So if we draw the free body diagram, so upward force would be the thrust, let us call it T, and downward force would be mg, force due to weight of the rocket. Okay, so net force T minus mg is causing this acceleration A, So it would be m into A. We have to find the thrust. Therefore thrust would be m into g plus A. So this would be 2 into 10 to the power 4 multiplied by, we have to consider g as 10, so it would be 10 plus 5. So 30 into 10 to the power 4, which is nothing but 3 into 10 to the power 5 Newton. 3 into 10 to the power 5 Newton. Therefore initial thrust or force is 3 into 10 to the power 5 Newton. As straightforward as that. Question 5.10. A body of mass 0.4 kg moving initially with constant speed 10 meter per second to the north is subject to a constant force of 8 Newton directed towards the south. So if we take the rightward direction as north, the force is towards left. We have to take, and the important point to remember is the force only acts for 30 seconds. So we have to take the instant the force is applied to be time t equal to 0 and position of the body x equal to 0. So we have to write its position for t1 is minus 5 seconds. So 5 seconds before the force is applied. T2 is 25 seconds and T3 is 100 seconds. T3 is 100 seconds. So let us first write all the equations and then let us proceed one by one. So first let us write all the equations. So initial velocity u is 10 meter per second. Acceleration would be force divided by mass. So it would be 8 Newton divided by 0.4, which would come out to be 20 meter per second square. Acceleration would come out to be 20 meter per second square. Now this acceleration only acts after t equal to 0. Okay, so before t equal to 0, there was no acceleration. Therefore, position, so x at t1 would be u into t. So that would be 10 multiplied by minus 5. So this would be minus 50 meter. So that would be minus 50 meter position at t equal to minus 5. Then we have for x is equal to t2, the motion we have u t plus half 80 square, because from 0 to 25 seconds constantly force is being applied. Now this 20 meter per second we calculated is the magnitude of the acceleration, and that acceleration is opposite to the initial direction that we have taken as positive. So in actuality this acceleration has to be minus 20 meter per second square. So let us calculate x at time t2. So 10 into time is 25 plus half into acceleration is 20 and time is 25 square. So this is 250 plus 10 multiplied by 625. So this is again minus sign here. So this is minus 6250 plus 250. So this would become minus 6000 meter, which is minus 6 kilometer. So now the position would be 6 kilometers towards the south. 6 kilometers towards the south. And third case, T3 is 100 seconds. So let us divide this motion in two parts. Why do we need to do that? Because for the first 30 seconds, force is being applied, but after that, force is not being applied. So let us divide 0 to 30 seconds and 30 to 100 seconds. 0 to 30 seconds and 30 to 100 seconds. So for 0 to 30 seconds, what will happen? X would be, let us call it x1. So x1 would be ut plus half 80 square. So this would be 10 into 30 plus 1 by 2 into minus 20 into 30 square. So this would be 300 minus 10 into 900. This would be 10 into 900. So this would be minus 9000 plus 300, which is minus 8700 meter. Minus 8700 meter. Now what would be u1? u1 is the velocity at the end of 30 seconds. It would be u plus 80. So it would be 10 plus minus 20 into 30. So this would be minus 600 plus 10 minus 590 meters. Minus 590 meters. Now from 30 to 100 seconds, u1 will remain same, which is minus 590 meters. Time span is 70 seconds. Therefore, distance traveled is Therefore, distance traveled, let us call it x2, is u1 multiplied by t. So minus 590 into 70. So it is 963. 41300 41300 meter. 41300 meter. Minus 41300 meter. Therefore, x of t3 would be x1 plus x2. So this is minus 8700 plus minus 41300. This is minus 50,000, which is minus 50 kilometers. So position after 100 seconds would be minus 50 kilometers. Position of the after 100 seconds would be minus 50 kilometer. The important point here to remember is that the force stops acting after 30 seconds. If you don't do that, if you don't consider that, you will get the wrong answer. Read the question carefully. Let us move to the next question. Question 5.11. A truck starts from rest and accelerates uniformly at 2 meter per second square. So acceleration of truck is 2 meter per second square. At time t equal to 10, a stone is dropped by a person standing on top of the truck. And it is at a height of 6 meter from the ground. So this height is 6 meter. Okay. So we have to calculate velocity and acceleration of the stone at time t equal to 11 seconds. So stone is basically being dropped for just 1 second. Now, because the truck is accelerating and stone is on the truck for the first 10 seconds, it will have a horizontal component of its velocity. Let us find that. So Vx, its horizontal component will be, u is 0 initially because starting from rest. So it will just be 80 multiplied by time t. So 2 into 10, which is 20 meter per second. So for the stone, it will have constant velocity of Vx is equal to 20 meter per second while being dropped. So that will not change. After that, what do we have? After that, we have that the stone is being dropped at time t equal to 10 seconds. So their vertical velocity is 0 because the stone is being dropped. So first we will see whether in 1 second how much distance it will cover and what will be its velocity. So at 1 second, distance covered would be initial velocity is 0. So half gt square. So it will be 1 by 2 into 10 into 1. So 5 meter. So it is not reaching the ground at 1 second. So we are good there. And velocity is v is equal to u plus 80. U is 0. So it will be just 10 meter per second. So here Vy is equal to 10 meter per second. Vy is 10 meter per second. So what will be the net velocity? Net velocity would be root of Vx square plus Vy square, which would be root of 20 square is 400 plus 100, which will be root of 500, which is 10 root 5. 10 root 5 meter per second would be its net velocity. And what would be its direction? If this angle is theta, then tan theta is 20 by 10. So theta is tan inverse of 2. Theta is tan inverse of 2. So magnitude of the velocity would be 10 root 5 meter per second, and its direction would be tan inverse of 2 from the vertical. Tan inverse of 2 from vertical. So that would be magnitude and direction of its velocity. Now what about acceleration? Now that the stone has left the truck, it will no longer accelerate in the horizontal direction. So only acceleration that it will experience is the gravitational acceleration, 10 meter per second square downwards. 10 meter per second square downwards. So this will be the velocity and this would be the acceleration. A bob of mass 0.1 kg hung from the ceiling of a room by a string of 2 meter long is set into oscillation, oscillating back and forth. Speed of the bob at its mean position is 1 meter per second square. So this is 1 meter per second square. What is the trajectory of the bob when the string is cut, when the bob is at one of its extreme position and its mean position? So at the extreme position, it has no horizontal velocity and no vertical velocity, is momentarily stationary. Therefore, if the string is cut there, what will happen? The bob will just fall below. The bob will just fall below. So it will be fall below. It will be a free fall. But now what about at the mean position? At the mean position, it has a horizontal component of velocity, but no vertical component of velocity. So what will happen? The ball will move in a parabolic path. So ball will move in a parabolic path. Okay. So horizontal component will remain the same, but due to acceleration of due to gravity, it will gain a vertical component. So it would fall in a parabolic path. Let us move to the next question. Question 5.13. A man of mass 70 kg stands on weighing scale in a lift which is moving. So we have to find the reading on the scale. First one, when the lift is going up with uniform speed of 10 meter per second. So if the lift is going up with uniform speed of 10 meter per second, the normal will be equal to the mass into acceleration due to gravity, which is weight. And we are calculating normal on the weighing scale. Therefore, that will not change. So mass will come out to be 70 kg. For the second one, the lift is going downwards with uniform acceleration of 5 meter per second square. Let us draw its free body diagram. So we have normal force which is being counted on the weighing scale, and we have mg. Okay, now acceleration of the man is downwards of 5 meter per second square. So we will have to calculate the normal force and divide it by acceleration due to gravity divided by 10 to get the reading. So normal force would be mg minus m into 5. So this would be 70 into 5. Therefore, the reading would be mb, let us call it. It would be n upon g. So that would be 70 into 5 upon 10, 35 kg. So here reading would be 35 kg if the lift is going downwards with acceleration of 5 meter per second square. Now for the third condition, if the lift is moving upwards, okay, so this is normal n, this is mg, and lift is moving upwards with 5 meter per second square. Again we will do the same thing. Normal now would be mg plus m into 5. We have to find normal by g, which is equal to mc, mass in c condition. So that would be 70 into 10 plus 5 upon 10. So that would be 7 into 15, which is 105 kg. So in the third condition, the mass shown on the weighing scale would be 105 kg. And fourth condition is what would be the reading if the lift mechanism has failed and it is hurled down freely under gravity. If the lift mechanism has failed, there would be no normal force because everything will move below with acceleration g. Therefore, reading would be 0. So in D condition, reading would be 0. So first condition reading would be 70 kg, second condition reading would be 35 kg, third condition reading would be 105 kg, and fourth condition reading would be 0. Reading would be 0. The figure shows position time graph of particle of mass 4 kg. What is the force on the particle at t less than 0, t greater than 4 second, and t from 0 to 4 second, and we have to find the impulse at 0 and 4 second. It is a one-dimensional motion. Now this is position time graph. Position time graph is a straight line. So here position is not changing, so object is at rest. Here it is a straight line motion, so constant velocity, and here again at rest. So there is no acceleration anywhere, therefore force is 0 in all cases. No force is acting. But what about impulse? Impulse is change in momentum. So at t equal to 0 second, final momentum is here speed from 0 to 4 seconds is 3 divided by 4 meter per second. So speed is, impulse would be 3 by 4 into 4 kg's mass, 3 by 4 minus, initially speed was 0, so 0. So it is 3 kg meter per second. 3 kg meter per second, impulse at 0. At t equal to 4, final momentum is 0, initial momentum is 3 by 4 into 4, so it is minus 3 kg meter per second, minus 3 kg meter per second. So force everywhere is 0, and impulse at 0 is 3 kg meter per second, and impulse at 4 second is minus 3 kg meter per second. Okay, it is a one-dimensional motion. These were pretty simple, pretty basic questions. Hope your queries were cleared. Hope your concepts are perfect. In the next video, we'll move to further questions which would be a little bit more challenging. See you then. Thank you.